Okay. Welcome everyone to our next talk. This is going to be Ruan Pretorius from Melio talking to us about evaluating LLMs. And before I hand over to him, I also just want to do a reminder. Sign-ups are open for the lightning talks, everyone's favorite, well, my favorite bit of the conference. For people who haven't done it before, short 5 minutes, anything Python or Python-ish related. And to sign up, just send an email to team@za.pycon.org with the title of your talk and like a one-line description of what it's going to be about. If you forget that email address, come and ask me or someone else with an organizer badge. It's very low pressure. If you've never done a talk before, this is a good opportunity if you do a talk. Okay, great. Over to Ruan.
Thanks, everyone. Thanks for joining this talk. We'll be talking about monitoring and evaluating LLM apps today, and we'll specifically be looking at an app called Langfuse to do that. So, as mentioned, I'm Ruan. I'm a data scientist from a company called Melio, and we help you to deploy and build your data-intensive apps. So please follow us on LinkedIn. We post a couple things there often, and you can also follow me on GitHub. I will have the slides and all the code for this available on GitHub. I'll share QR code at the end, so you don't have to take notes or pictures or whatever just yet. So a little bit about what we're going to be going through. We'll start with, first of all, why even monitor and evaluate your LLM apps, and then we'll look at some setup. So for this, there's a theme I want to be going through in this talk where we'll do everything locally. So we'll use local LLM apps and set up Langfuse locally. So you can do this for zero cost prototyping. And then we'll look at monitoring with Langfuse and some evaluation, and then do some conclusions. So why do you want to monitor and evaluate your LLM apps? So it's mainly to ensure quality and performance, so you can track hallucinations. Maybe if you have a RAG application, you can assess the retrieval accuracy to see if it's retrieving the right kind of stuff from the knowledge base. You can track latency, etc., so you can maintain a high quality user experience. You can also detect errors and see things like harmful outputs, so that you can, all of this is to identify areas of improvement in your app so that you can reduce costs and latencies and improve your answers, etc. And also if something goes wrong, you can see where it goes wrong and dive a bit deeper into why it goes wrong, so that if you want to fix it, you can have a more targeted approach. So just a real quick high-level overview of some of the components we'll be looking at. Starting at the bottom right here, we'll set up our language model locally with Ollama, and then our app logic will be interacting with that language model. We can use something like LangChain to code that up. And then we'll have a Langfuse server as well, which we'll be actually sending the traces to for the monitoring. And just for a little bit of detail, we won't actually look at it specifically, but just to know that Langfuse is backed by a Postgres database. So that's maybe also more of use if you want to self-host this. And then this Langfuse server also has a web user interface which you can interact with. And if you wanted to build a front end that interacts with your app logic, you can also interact with it through there. And ultimately, all the traces will be sent to Langfuse. So you'll see some of those components coming through as we go through it. So to start off, setting up Ollama. So we have a language model to use locally. This is a nice piece of software for running LLMs locally. And it's available on macOS, Linux, and there's a preview version in Windows as well. And if you've used Docker before, you'll find it quite familiar. It's got this colon version syntax, and you'll see pull and run commands, which you might be familiar with. So first of all, you can just head over to Ollama to download it, and then browse their model library. They've got quite a bit of models. They've got even some multimodal models. So once you've selected one, you can run the pull command and just type the name in that you want which model you want to use, and then they've usually separated them out. these versions with like the size of the model. So in this case, it'd be the 8 billion parameter model. And then once that's downloaded, it takes a while, depending on the model size. But once it's ready, you can just run it with the run command like that. And it'll look something like this. You can run it in your terminal and then just ask it a question. This is the speed that you can expect from running that 8 billion parameter model on some hardware like this. This was, I think this has like 16 gigabytes of RAM. So it's pretty fast for local LLM. There you go. Okay, so now we have our language model set up. Now we need to look at Langfuse. So I mentioned a little bit about it before, but just to go over it in some more detail, it's an open source LLM engineering platform, which will specifically look at the tracing and evaluation of it today, but it has a couple of other features as well, like prompt management, etc. And this is the useful tool that we can use to debug and improve our LLM apps. So like I mentioned, you can self-host it if you may be worried about the privacy more, or you can use it as a service. So yeah, as we go through this, you'll see me use this like terminology. So this is like how things are broken down and represented in Langfuse. So a trace usually represents like a single request or operation of your app, and this will contain the input and like the overall output. And then your app might do like sub steps within this where you'll track these as observations, and they can have different types. So span will be like a more general type of work step of some duration. And then there's also a special type of span called generation, which is kind of reserved for when you use an LLM or some generative model to produce something as a step in your whole workflow. And they contain some extra metadata like token usage and model type, etc. So just to give you like a quick view of what this might look like once you set this up for, let's take for an example, a RAG application. This is like a screenshot from the Langfuse dashboard where you can see this is like a single trace with some sub-steps which were captured as these spans. And you can see the overall input for this trace and the final output. But then you can also see, I mean, this is probably what you'll see from the user interface anyway, the input and the final output. But then what makes it useful is you can dive into like the sub-steps and like what it actually do. And you can see the step here where it actually searched something from the vector store and then augmented the prompt with that context that it retrieved before passing that to the LLM. And you can even see like how long each of these steps took. So that starts to give you an indication of where like maybe some performance bottlenecks are and so on. So how do we set this up? Like I mentioned, there are two options. If you want to use it as a service, you simply sign up at Langfuse at their website, and you can pick a region where you want to host it. I believe they have EU and US only for now. And then once you do that, you just log in, create a project, and then generate some API keys so that you can use that in your code to like, so that it knows which Langfuse server to actually send it to, and it'll like appear in your project. And for the local theme of this talk, I'll also show you how to do do it locally with Docker Compose. And for this, you'll need Docker and Docker Compose, which you can get by just installing Docker Desktop. And to get that Compose file, Langfuse recommends that you head over to their GitHub repository and just pull it. And you can run Docker Compose up, and it'll set everything up for you locally. And then finally, once you have like the infrastructure set up, you can simply pip install the Langfuse package, which will give you like a Python SDK that we'll look at a bit now as well, so that you can actually talk to your Langfuse instance. And remember earlier you would have generated the API keys, so you can just export them as environment variables, as well as the host. Like maybe if you use it as a service, you would point it here, or you can point it to your local instance. And that's all the Langfuse setup. Now we have, if you would have done this locally, you would have your Langfuse server at port 3000, as well as that Postgres database where it like keeps track of everything. And we've installed the Python package and used those environment variables to point it to the correct instance. And now we are actually ready to use it. This is kind of what it looks like in the Langfuse dashboard. So you can see an overview of like the volume of your traces, the latencies, and like different percentiles of how long it actually takes your application to respond. You can track costs, and you can also drill down deeper into the actual traces like I showed you before, where you can like see the overall input output and dive deeper into the steps of like how it got to that for some debugging. So how do you actually get your code to talk to Langfuse? That is the process of instrumenting your code, and I'll show you two ways of doing that. So first of all, we'll look at the Python decorator, and this is more of a lower level way of doing it. And there's like a little bit more automated way to do it as well with the LangChain callback handler. I'll show you the LangChain one, but there's actually one for Ollama index and a couple of popular frameworks as well. So starting with the decorator way of doing it, you can simply import this observe decorator from Langfuse, and you can actually use this with any Python function, where you can just slap that decorator at the beginning of your function, and it'll be observed. It'll send the traces to Langfuse. So you can customize a lot of what it does, but I think for now we'll just go through the default behavior. So in this example, we have two functions here. Well, let's say the first one calls some LLM with some prompt input, and it just responds with like a string response. And the second one is where we can maybe call that function with something specific, like tell me a story. And remember, just for the next slide, that the get story calls this first call LLM function. And that's how you can set up the nesting. So when you run this is what it actually looks like in Langfuse. So you get this, you'll get all the spans, and remember, like I just mentioned, the nesting depends on like which function called which function. And the top level one will automatically be called the trace, and then it'll have its sub-steps inside it. Now this is quite a simple one, and if you remember, the get story, we didn't have any input arguments for this, and that's why it shows like no input arguments here. But if you passed anything in there, it'll show up here. And you'll also see that by default the trace and the spans are called the same as the function names, but you can also customize this to make it more, I don't know, if you don't want underscores or something like that, you can change that as well. Yeah, so that might take quite a bit of time if you have a lot of code and you have to like manually instrument it. But if you have something like a LangChain runnable, you can just use the callback handler, and it'll automatically instrument some of the code for you. And this can be like a faster way, especially if you already have like a LangChain runnable. So again, all you need to do is import the handler, instantiate it, and whenever you run your LangChain runnable like a chain, if you call the invoke method, you can pass it the whatever inputs it expects, and then you can just add this config argument where you point it to the Langfuse handler, and when you run it, it should look something like this. This is the same screenshot we looked at before for that RAG example. So you can see it like breaks down the steps for you. So that can be quite a quick way of getting started if you're using like Ollama index or LangChain. All right, now that we have instrumented our code and we can monitor what it's doing, you might want to move to evaluating the app. So in Langfuse, there's a concept of a data set, which is how you can capture a set of inputs that you would pass your model, your app, as well as expected outputs. And once you've created it, you can run different versions of your system through this data set, and it's useful for tracking the performance over time, or like doing some testing before pushing it to production, for example. Yes, you can also attach a score to this trace, and that's where the evaluation would come in. You can do this, basically give a rating for how it responded, either in the Langfuse dashboard, sort of like a human evaluation, or you can automate this using another LLM to judge how your app responded, and this will be referred this is referred to as LLM assisted evaluation. So this is all useful to create like a feedback loop and improve your system's performance over time. So looking at this screenshot from the Langfuse documentation, I think this shows a nice flow of how you might use a data set. So like I mentioned, you would create some input-output pairs, and then those would be the items in your data set. And once you make a change to your app, you can pull in one of the inputs from an item of your data set, have your app generate some output, and then compare that to the expected output and do some evaluation. And I'll also show you where you can see like an aggregated result of your app version, so you can quickly make decisions on which version you prefer, or like as a test step before pushing to production. So you create a dataset in Langfuse, you can instantiate a Langfuse client like this, just simply import and instantiate it, and then it gives you access to a couple of useful methods like create dataset, where you create a named dataset. And once it's created, you need to populate it with your set of input-output pairs that you want to use to evaluate your dataset. And you can read this from a file or anything, but once it's captured in a form like maybe a Python dictionary like this, you can simply loop through it, and that client has another method called create dataset item, where you just point it to the dataset that you wanted to add it to, and you pass in the input and the expected output. And once you've done that, you can, in the Langfuse dashboard again, you'll see there's a datasets tab here, and your datasets will appear there, and you can see some detail about them, like how many items are in there, when you created it, etc. So then once it's ready, you can again use your Langfuse client to pull that dataset, and it's identified by its name, so you just pass it the name to get the right one, and then you can simply loop through the items again and go about your evaluation. So each item also has a couple of useful methods and attributes linked to it. So when you invoke your agent or app, it's useful to not only get the actual generated output that you're interested in, but to get the Langfuse trace ID so that you can link it, like I'll show in the next step. So you can access the input question by using the input attribute, and it also has this expected output attribute to access those parts of it. So to link a trace that was generated, so you invoke your app in this first step, and it'll create that trace in Langfuse. But if you want to link it to this dataset run, you can use this link method to do that, and you can give your run a name, and it's quite useful to separate this by like versions of your system, so that you can, once you view the aggregated metrics, which I'll show you now, you can do like a quick comparison. And then, you can stop at that point, but if you want to attach an evaluation metric to it, you can run some function that maybe outputs a float that depends on the output and the expected output. You can attach that value to the trace using the score method. and you simply point it to the trace that you want to attach it to. That's where that trace ID comes in useful. And it's like a named key value pair. So you give it your metric a name and you attach a value. So it's quite flexible. You can add any numeric value. I think it also supports some like Boolean values or string values. So yeah, I mentioned before that you can do it programmatically with that score method, or you can do it in the dashboard. There's an annotate function which you can use for human evaluation. And if you actually click into a data set, you're presented with this view where you can see the different runs that you've done. And if you separate it by your system version, you can quickly, at a glance, see like aggregated scores, and you can maybe use this to inform decisions of like maybe you prefer promoting this version 2 to production because it has better answer correctness or something like that. So just a couple of tips and caveats about this LLM assisted evaluation. It's not like a magic silver bullet. It can help because it's quick to get feedback since it's like automated. But I would rather just use it to inform your priors and look at the direction it's pointing you in rather than fixating on the absolute values that it's giving you back. And also, it depends on the problem you're trying to evaluate. There might be some better options. Like if you're doing code generation, for example, you can just run that code to see if it actually works rather than asking an LLM if it will work. So yeah, also if you still want to use it, consider a chain of thought to improve the results of your evaluation, and also have humans double check your LLM evaluations. So yeah, that was just a real quick overview of Langfuse. I mentioned before that it has some other features, and they bring out new updates quite regularly, so do check it out. They are open source. It's got a low performance overhead, and they also support multimodal tracing. And since it's open source and there's a public API, you can customize it for your own integrations as well. They don't have what you're looking for yet. So yeah, and finally, there are some alternatives to this as well, so you don't have to use Langfuse. Some are Arise Phoenix or Langsmith. I think Langsmith was like the OG of this. But yeah, so consider Ollama when you want to do some zero-cost prototyping and learning, and Langfuse if you want to help with monitoring and evaluation, to set up this nice feedback loop which you can use to like iteratively refine your apps. So yeah, happy experimenting. There's a couple of references, and you can scan that to see the repo if you want to play with this yourself. Thanks.
By the fullness of the room, everyone wanted to hear about that. Thank you for the talk.
Sure.
Do we have any questions? I'm sure we will. Here we go.
Firstly, thanks for the talk. Just a quick question. You kind of mentioned evaluating different versions of your model. Can you also use it to compare different LLMs and not just different versions of models?
Yeah, for sure. So I guess maybe you could say you evaluate different versions of your whole system, but you swap out the LLM piece, and then you can do the same thing to assess. Yeah, because definitely. I mean, maybe some LLMs are like more advanced than others. Some are faster than others. So it depends which metrics you're interested in as well. And your prompts might even not perform well on, like some prompts perform well on.
Yeah.
So yeah, you can definitely do that. Yeah.
Okay, thank you.
Oh,
Thanks again. For the auto orchestration with the callback, did you ever find it like too chatty? Because we found sometimes it would often log too much information.
Yeah, yeah.
Were you able to solve that?
I think that's a good question. I think it does sometimes. You don't really have control that much if you, I think, use the automated way of doing that. But probably the best way to, let me just go to that. Yeah, this one. You can probably do the decorator method if you want like more control over how it shows up. Yeah, that's what I would do. Yeah.
Hi. So I was curious about the actual validation data sets, right? So obviously you need to do an input query and then you've got your expected outputs. Does it do any sort of like natural language matching on that input query for like similar queries, or like do you have to do per variation of that question a whole new data set?
I'm not sure if I understand the question, but you kind of have to manually set these up.
So they're fixed questions, like so like it wouldn't be
Yeah.
like you have a question like how many cars do I have, and then the question is tell me how many cars I have. Like would it match in that
Oh,
level?
I see.
Yeah.
You can probably have another step in between in your evaluation where it like elaborates or like phrases it differently before sending it to your
Passing
system.
it back to an LLM basically or something.
Yeah, yeah. But I think I would probably store all those versions in a Langfuse dataset so you can have the same ones to pass to all versions of your system. And yeah, yeah.
Do you know, does it output to like sort of like cloud monitoring, like sort of like Azure Insights and that sort of thing?
I think the main idea of Langfuse is to like capture it in that one place,
Yeah.
as far as I understand. But you can probably send it out to Langfuse and
manually,
something else.
yeah.
Yeah, yeah.
Thanks.
While I'm walking over there, I'm going to ask my own question. So, are you using these tools in products for your business, and how effective are they? That's my question as someone who hasn't started using them yet. And how hard are they to get to work well?
The LLM apps themselves are hard to get to work well. Like it depends on the use case really. But we found Langfuse quite useful to just like have a good overview of what's happening, and like if you can use it to see where things are going wrong so that you can come up with a hypothesis or approach to, you can see what you can do to have the most impact, and then you can evaluate and see if it did have an impact and so on. Yeah, so it's quite useful. We've been using it.
Is Postgres the only supported database for Langfuse?
I'll have to double check the documentation. I think you can swap it out, but maybe just double check the documentation for that. I think Postgres is the default. Yeah.
Thanks. I quickly have a question. You said the direction is better. Is it maybe then better to use an ordinal rather than a float? So like say good, bad, or maybe, rather than something between 1 and 10. Does that make sense?
Yes, yes. I read somewhere that a good way to also pose the questions is to say, compare this output to this one and like pick one. That's another thing you can do. But I think it definitely it could help to kind of constrain the space of the output of this evaluation a little bit. Yeah. And what I also meant was that these metrics will be produced by calling another LLM. So if you use off-the-shelf prompts from libraries like Raygas or something like that, I think it's worth looking into the prompts to see if it suits your particular problem, because maybe it wouldn't understand the nuances of your subject quite like, and then so you can compare different versions of these to each other, like relatively, as opposed to looking at, oh, okay, that's like 60% answer correctness, that must be bad, that kind of thing. That's what I meant. Yeah.
Thanks for the talk. You've mentioned quite a bit on sort of the automated comparison and everything, but you mentioned in one slide there's also human scoring. Can you just tell us a bit about how Langfuse facilitates that process?
Sure. I don't think I have a screenshot that shows that, but there's a way where you can create a set of like metrics that you want to track. Like, let's say you want to create a Boolean one, like, is this a good answer or not? Just like a simple yes, no thing. So you would create that in your evaluations in Langset. And then when you go through a trace, maybe there's a screenshot of this. Yes, there we go. See that annotate button? If you hit that, it'll like bring up a new window where it shows you all your evaluations that you created, and the human can just go click on there, and they can add a comment as well, so that when you look at that aggregated view like this, you can see like all the automated metrics as well as your human generated metrics, and still get an overview like that. Yeah. Does that answer the question?
Yeah, thanks very much.
Hi, thank you for the talk. I had a question about, going from blind prompting to using evals to kind of figure out what's going on. Have you been surprised at some of the tweaks that actually make the biggest difference in solving problems?
So we use this quite a bit for agents, like RAG agents. And what was definitely useful is to, in one place, see to log the agent reasoning and to see why it selected a tool. So you can often use that to improve the tool selection at least. And then also you can see what comes back from the knowledge base, so that you can, I think that's probably where most of the work is, like updating the knowledge base and the way that's structured, and like how do you chunk things in your vector store, that kind of stuff. So yeah, definitely help to like gain those insights. Yeah.
Amazing. So I have a suspicion that across this room, there are lots of people who are dabbling in this or full on working on this at work, and that you guys would like to speak to each other because everyone's kind of figuring it out. So, I'm going to say, if that is you, put your hand up. There are more. Come on, put your hand up. And look around and look at each other. I'm serious. Look around and look at each other and go find each other over lunch or over coffee. You got to put your hands up properly, guys. Unless you don't want to talk to anyone. If you're shy, I suppose. Well, there's a few people who put up their hands up properly. Go find them if you want to talk to them. Or, of course, come and speak to Ruan over tea or lunch or whatever. Thank you so much, Ruan. We appreciate the talk and the effort and the insight.
Thanks, everyone.